Hello, my name is Marcelina Lirius and welcome to Math Monday. In this video, we're going to work on sample released items that are aligned to the Algebra 1 standard A1 LQ A1. Determine that linear functions change by equal differences over equal intervals, and recognize situations in this quantity changes at a constant rate per unit interval relative to another. Before we get started, please be ready with your supplies. You will need a pen, paper, and a calculator. So this first item is a multi-select item. So when you encounter problems like this, you are to test all options given, and usually multi-select items have at least 2 correct answers. So this has 6 choices. So we'll test all of these choices. Okay, so which table represent linear functions? So again, when we say linear functions, they change by equal differences over equal intervals. So let's look at the intervals here. Equal intervals, you have 1 and 1. And the differences, let's check if they're equal. Okay, 4 from 3 to 7, 7 to 11, 4 and 4. So our conclusion is this table represents a linear function. Okay, let's look at the second one. So from 1 to 2 over these intervals, do we have equal differences? So you now have the difference here. We move from 1 to 4, you now have 3. We move from 4 to 9, the difference here is 5, and the difference here is 7. Okay, so our conclusion, this table does not represent a linear function. Let's consider the third option. So for letter C, again, if we move from 1 to 2, 2 to 3, 3 to 4, do we have equal differences? Okay, from 3 to 6, you have 3. From 6 to 12, it's 6, and here it's 12. So our conclusion, this does not represent a linear function. Then for letter D, you try this first on your own. Check if this table represents a linear function. Okay, look at the intervals, okay? Again, over equal intervals, will there be an equal difference here for differences? So we have 0.5 and 0.5. Okay, from 2 to 2.5, there is a difference of 0.5. So this is a linear function. Okay. How about the last two? I'll give you a moment to try this on your own first. Get your pen, get your notebook. Let's see if we arrive at the same answer. Okay. Again, you have here equal differences. Let's look at the difference. From negative 50, if you move to negative 45, there is a 5 unit difference. 5 and 5. Okay, you can also visualize this as if you are on the number line, how far do you move from negative 50 to negative 45? Remember, if you have negative numbers, you're moving actually here from negative 45, you're moving to the right. So you move 5 steps to the right. And this is representing a linear function. Okay. For letter F, what do you think? Just by looking at the numbers on the Y column, do we have equal differences? This is 19, and this one is 37. Could you double check? Okay, now, later on, you might discover that this will represent a different type of function. Okay, if you have 1, 8, 27, 64. Okay, this is not a linear function. I'm sorry. This is not a linear function, so we cross this out. So going back, of the 6 choices we arrived at, okay, you have letter E, letter D, and letter A. So there were 3 correct answers: letter A, letter D, was it D? And the last one was E. So again, for multi-select, careful, you have to test all the options. There are at least 2 correct answers. Okay. Ready? So in the next item, we are given a table with points that are on the graph of a linear function. So this is already predefined that this table represents a linear function. So we are asked which function represents the same relationship. So we are asked which of these equations here would represent the table of values. So we have here h of x, and remember our function notation, y is equal to f of x, or in this case, our function name is h. So we can replace y with h of x, or h of x with y. So going back, you have the equation y equals mx plus b. So this is the slope-intercept form of the line. So we have points here, the ordered pairs x and y, So we have the ordered pair for x, negative 7.5 and 12, negative 3.5 and 0, negative 1, 7.5, and so on. So we can have, actually, these values, we can take a point, x and y, any point on the table. And our goal here first is to find our slope. So if you remember the slope m, we have the formula m equals y sub 2 minus y sub 1, or the difference in y over x of 2 minus x of 1. So if we take a point on the table, so we can take one ordered pair. So if this is our x of 1, if we have negative 3.5 as our x, the y value is 0. So we have an ordered pair x of 1, y of 1. And we can take another pair, which is our x is negative 1 and y is negative 7.5. So with these values, we're going to substitute this and find the slope, m. So m equals, this could be our x of 1, y of 1, and this is our x of 2, y of 2. Okay, so start. Y of 2 is negative 7.5, okay, minus y of 1, which is 0, over our x of 2, you have negative 1 minus negative 3.5. I'll stop here. We're just substituting the values. So m here, if we simplify, gives us negative 7.5 over, this becomes, okay, this becomes plus. So if we simplify, minus 1 plus 3.5, this will give us 2.5. So the value for m here is, get your calculators, this is negative 3. So now we have the value of m. Our next step, after finding the value of m, is to find the value of b. We need our b and m. Okay, So our B now is, we have y equals mx plus b. So we already have b, and to solve, we can substitute or take any value for x and y here. So I will choose a more convenient point, which is the negative 3.1, 3.5 and 0 as my x and y. Okay, substituting, y will be 0. We already have our m, which is negative 3, which we found earlier. And my x is, from this point here, I will have my x is 3.5 negative plus b, which is unknown. Okay, simplifying, negative, negative, here will be positive. So this will be positive 10.5 plus b equals 0. Then solving for b, subtract negative 10.5 from both sides. So our b is negative 10.5. Okay, so we now have our values for m and b. So of these equations, let's look at this. Y equals mx plus b. So if you're taking the test, just look at the, you can eliminate already. We already have negative 3 as our slope, so this is eliminated. Okay, this is eliminated. Even without solving for b, we are already able to eliminate these 3 choices. So the first choice here is actually the correct answer, and it represents the same relationship as the table of values provided. Okay, so m is negative 3 and b is negative 10.5. Okay, give you time to process. So that concludes our session for today, and I hope to see you next week.